But I think we should leave that on for a little while, right, Mom? Yeah. There's strontium hydroxide. HCl is hydrochloric acid. The mechanism of this is kind of double displacement, in that the strontium and the hydrogen ion will trade places. It'll make water, which is a pure liquid while the reaction occurs. And strontium chloride will be made. Balance the equation by putting a 2 in front of the HCl and a 2 in front of the water. If you look at this how-to sheet, I break it down then into 3 steps, part B, C, and D, of how to do this calculation. In part B, when I refer to the known thing, I'm given both the molarity and the volume of the hydrochloric acid. Molarity times liters equals moles, so that's going to be my first step. And I can do all the numbers for you because I already have it written down. And I'd recommend whenever we're doing any type of stoichiometry, especially solution stoich, which we're not as comfortable with as, say, the gram-to-gram version, that we label things. Not just moles, but moles of what? HCl. I'm going to use different colors. In the next step, this is the actual stoich of using the coefficients in the balanced equation to convert from one thing to another. I want to get the strontium hydroxide from HCl. Again, a lot of you only write the numbers in the conversions. I think writing of what is important as well. Step 2 is done. Step 3. Take moles and divide it by liters. That gets me molarity, which in the question adds 20 milliliters. Most commonly, people think of titrations being done with acids and bases, which is true. Which is why this sample problem is a base, something with a hydroxide, and an acid starting with hydrogen. However, it can be done for other things as well. It can be done for redox, but like what we're going to be doing later in the week also. I want to point out 2 things to kind of wrap up going over this. The first is, if you were to look at my answer key for problems that are solution stoichiometry, I don't break it into 3 steps. I do it like you guys do gram to gram stoich. I just do one row of conversions and I just solve it all at once. It's a little more confusing for students early on to do it that way. However, there's a benefit of it. It saves you time and space if you get used to that. So I'll show you how I would set this up instead. I'm just rewriting molarity as moles per liter, because that's what molarity is. The reason why I write it that way is it allows me to cancel out units pretty easily then. So I'm going to multiply by my liters in that step 1, which was the 4303. That way liters cancels out here and here. Gives me moles of HCl. Then there's 1 strontium hydroxide for every 2 HCl. That allows HCl to cancel out. I'm now in moles of strontium hydroxide. There's my 20 milliliters. It's the same 3 steps, but I just do it all in a row and then I solve. So that's the first thing I want to show you. The last thing I want to show you is what's referenced on this how-to sheet. Number 1 was use solution stoichiometry. Number 2 says use dilution math plus balanced equation. Just a minute ago, we might have been doing dilution math. What's the equation for dilution math? M1V1 equals M2V2. Bless you. When you do M1 times V1, remember M1 is just moles per liter. When you multiply moles per liter times liter, liters cancel out. You want the moles. The reason why I say you could use dilution math, when you dilute something, the moles of solute remains the same. You're just adding more water. You're spreading it out more. You're making it less concentrated. If we use the same equation in a titration, what it's saying is the moles of acid would equal the moles of the base. If it were a 1-to-1 ratio, that works. And quite frankly, why do solution stoichiometry, either the step 1, 2, 3 like I did black, blue, and green, or the all-in-one row across? Why do that if it's a 1-to-1 ratio and you can just do M1V1 equals M2V2? However, if it's not a 1-to-1 ratio, it's no longer the moles of acid equals the moles of base, because it might be 2 moles of acid equaling 1 mole of base. I'm not going to actually go over the bottom half of this sheet to show how to take that coefficient into account for that. What I'm simply suggesting is, if it were a balanced equation, if it were a 1-to-1 ratio, unlike this one, you don't actually have to do solution stoich. You can get there quicker by just doing M1V1 equals M2V2. However, if there is a coefficient, then you need to do solution stoich one way or another. Now, some of you might just choose to do solution stoich no matter what. That's fine by me. I just wanted to show you the other possibility that could be used to figure this out as well.